So today's topic 2, first day of our 3 days on it. Okay. Hopefully you have the learning goals down. Read about the reciprocal functions on the top of page 608. That actually is this guy right here. Okay. Top of page 608. There we go. So I want you to go ahead and read through that. And please note that as you're checking this out, when you start talking about the other 3 trig functions, the other functions, the cosecant, the secant, and cotangent, cosecant goes with sine.
That's cool.
Whereas secant goes with cosine. Now it almost seems like it's a little
Cool.
counterintuitive, right? Like you expect cosecant, the cos to go together and the s's to go together, but it's opposite of that. Okay, so cosecant goes with sine, secant with cosine, cotangent goes with tangent. The 1 over sine means it's a reciprocal. They're called the reciprocal functions sometimes. So the 1 over sine actually means the reciprocal of sine. 1 over cosine is the reciprocal of cosine. 1 over tangent is the reciprocal of tangent. Okay? We could write it like that if you think of tangent. If you think of having tangent of theta, writing that as a fraction would be that. And the reciprocal of that is 1 over tangent. You just flip it. Okay? All right. So we're going to go through these, and we're going to fill out the sheet that you picked up on the way in using this idea. All right? So taking a look at this page, you picked that up on the way in. I will caution you right now, I'm going to be expecting you to apply a bunch of your previous learning that sometimes hangs you up. So hopefully you're ready to put in some serious thinking here. Okay? Let's talk about how to fill this out. I'm going to skip down to pi over 6. I gave you the radians. You're asked to fill in the sine, cosine, tangent, cosecant, secant, cotangent, and the degree measure. And then you will use this page tomorrow when we're graphing these functions. Okay, so make sure it's accurate today. When I say fill them in, I want the exact values. Okay, so pi over 6. The sine of pi over 6. Your calculators aren't helpful. Well, I guess maybe for that one it is. What is it? What's that?
Sine 30?
That it is 30 degrees. That is the sine of 30 degrees. You're right. Okay? So what is the sine of pi over 6?
1/2.
Yes.
Root 3 over 2. Root 3.
No. Close.
1/2.
It is 1/2. Good.
That's what I said.
Dang it.
You said 1/5.
I said 1/2.
1/2.
1/5. Then I said 1/2.
What is cosine, Nicole?
Root 3 pi over 2. Root 3 over 5.
It's root 3. No. Exact. Yes.
Root 3 over 2.
Root 3 over 2. Thank you. Tangent. So the points aren't helping us here. Okay, we're going for exact values. Tangent. Now when we talked about unit circle, and we were figuring out what sine and cosine were, we had these different, for instance, let's go with, what are we dealing with, 30 here? Okay, so there's our 30.
Tangent.
We can drop this down. Okay, remember if this is theta, and this length represents, what does it represent? Cosine. This length represents sine.
And then the other one's tangent.
The other one is not tangent.
Okay.
The other one's just the 1. Okay?
Okay.
So when we're dealing with this tangent, well actually I'll show all 6 of them on a unit circle either tomorrow or on Thursday. But tangent is equal to, in this right triangle, how do we find tangent?
Sine over
Opposite over adjacent.
Very good. Opposite over adjacent. So tangent is equal to opposite over adjacent. And the opposite, and that's very hard to see, sorry. Good. So the opposite here we're actually calling sine. And adjacent is cosine. So tangent is sine over cosine. Tangent is always sine over cosine. Okay? So in this case, if we're looking at this problem right here, and we know tangent, we know that the tangent of pi over 6 is equal to the sine of pi over 6 over the cosine of pi over 6. We can think of that as sine of pi over 6 is actually 1/2. Cosine is root 3 over 2, and now you have a compound fraction. Okay, you have a fraction within a fraction, two fractions within fractions. The way we deal with that is we say this means division. Okay, we don't divide, we multiply by the reciprocal. We cancel, cross cancel, which gives us 1 over root 3. And we've got to now rationalize it. We've got to get that radical out of the denominator, so that becomes root 3 over root 3 that we multiply by that special number 1, which gives us root 3 over 3. Now can we cancel those 3's? No. One's a root, one is not. So this is root 3 over 3.
One of the 3 on top isn't actually.
Neato. Now we know that cosecant is the reciprocal of sine. So if you don't know that, you should write these up here. Like I would write, this is equal to sine over cosine. This is equal to the reciprocal of sine, or flip sine. Or if you actually understand the mathese, it's 1 over sine. Now the problem when I write it like that, I see students starting to write 1 over 1/2. They say, well, the cosecant of pi over 6 is equal to 1 over 1/2. And then they're like, what do I do there? Well, I go like 1, and then I got to divide. I know McCoy did this in class, and then he goes, that's actually 1 times 2 over 1. Oh, it's just 2. Woohoo! Yeah, it is, because it's just the reciprocal, man. You just flip it. Yeah, just flip it. That's 1 over sine means the reciprocal of sine.
Wouldn't it be
Okay?
negative 2 then?
No, the reciprocal. You just flip it. The reciprocal is what you can multiply this by to make 1. Okay? You flip the fraction. All right? So, just if you're writing that like that, make sure you know it. Maybe you make a note to yourself, means reciprocal.
Opposite reciprocal would be negative 8.
Okay?
Reciprocal is just flipping the sign.
All right. Secant. I'm running out of room here. Okay? Our secant is the reciprocal of cosine. So secant of pi over 6 is equal to 2 over root 3, right? We flip this. Well, 2 over root 3, can't have a radical in the denominator, so we got to multiply by root 3 over root 3 equals 2 root 3 over 3. This is 2 root 3 over 3. Everyone figure out what cotangent is. Okay. See if you got it right. Cotangent. Remember that's 1 over tan. So the reciprocal of tangent. So cotangent of pi over 6 is equal to, let's move that up just a bit, is equal to 3 over root 3. So we got to multiply by that special number 1. Most of you know that pattern now. You know the root 3 is going to move to the top, and the bottom's just going to be whatever's in the radical. Okay, those cancel, you get root 3. Okay, how many got it right? Very good. There we got it. Your job right now? Well, first, any questions?
Oh, goodness.
I will tell you there's tons of patterns here, so if you do this right, you should be able to quickly think of the unit circle. Okay, if you think of the unit circle and do it correctly, like this coordinate is just this coordinate. They're the same. It's just, yeah, it's just that x is negative here. Okay, and they're both negative here, x and y. All right. So if you really put some thought into this right now, prior to starting it, this table should go quickly. You shouldn't have to recalculate for every single one of these. But your goal right now is to accurately fill out this table. Okay? Here you go. Make sure we fill out that table right now. We got our root 3 for cotangent. Here are your solutions. Now I know that that's not really easy to read, but that's the only way I can put it. I could, but right now I want to have it up there for you to see every part. So if you have to come up to check a portion, you may have to move up a little closer. But there we go. Notice that I have pi over 4, 3 pi over 4, so angles of 45, with the exceptions of your 0, 90, 180, and 270 and 360. Okay, I have those highlighted. So I have my 45, my 135, so on. Got all those highlighted there. Okay. All right. How many of you found the patterns? Okay, just make sure you're accurate on it, right? If you're using the unit circle, I kind of hinted to it. Right, this guy right here, this coordinate is going to be the same as this coordinate over here, except for your x's are going to be negative. So remember, you have a negative positive here. Here you have positive positive, negative negative, and positive negative. All right? And so if you're thinking of it that way, when you're trying to fill these in, your pi over 6, that actually corresponds with your 5 pi over 6, right? So you got your 1/2, your 1/2, your, all right? Everyone see why that is? Here's pi over 6 right here, and here's 5 pi over 6. Okay? So the only thing that changes is the sign. So if you can relate it back to your unit circle, it's helpful. You need to have those values accurate tomorrow, or for tomorrow's graphing. The other thing that will help you tomorrow, if you want to get a head start, is to change each one of those to decimal form. Now that seems like a pretty daunting task, with the exception that really there's not a lot of different numbers there. Yeah. I mean, you're not changing you don't actually have to physically go in and put a decimal by every one. If you know root 2 over 2, that's used a lot here, and negative root 2 over 2 is just root 2 over 2 with a little negative sign in front of it. Right? So there aren't a lot of different decimals, but if you write maybe off to the side, the decimal form of root 2 over 2 is this. The decimal form of root 3 is this. Okay, that'll be helpful for you tomorrow. Put you that much further ahead. Okay. Any questions?
Did anyone figure out how to do that faster?
Yeah, they're using the pattern. You shouldn't be calculating every single one.
No, the thing from yesterday.
Oh, the graph from yesterday? Are you talking about finding the dependent bit? I haven't heard of anything yet. No. All right, so you can be working on your assignment now. Ask